Right, 2,148 to the nearest 100. So I'll look at my 100, look at my 4. My 4 is below 5, so it's going to be 2100. I simplify 8x minus 3x plus 2x. So it's just 8 minus 3 plus 2. I'll use my calculator paper. 7. So the answer is going to be 7x. Okay, simplify 4y times 2y. Let's do numbers first. 4 times 2 is 8. Y times y is y squared. Done. 6,760 people at a rugby match. 3,879 of the people are men. 1,241 of the people are women. A quarter of the children are girls. Work out how many boys are at the match. Now, I don't like this question because I would actually class boys as men, but in this class there is 4 separate categories of men, women, girls and boys. So girls and boys are children, men and women are adults, that type of logic. So first of all, we need to work out how many children there are altogether. Okay. Now you might want to go down the way of a two-way table or frequency table, but I don't think there's a need to in this question. So to work out the amount of children, I've got to do 6760 minus 3,879, which are the men, and minus 1,241 because they are the women. I'm just going to type that straight into my calculator. It's 67660 minus 3879 minus 1241 1640. So it's 1,640 children. Okay, a quarter of that are girls. So we can work out a quarter and subtract it, or if there's a quarter of girls, then we know 3/4 are boys. So I'm just going to times that by 3/4. My answer is 1,230. Here's a grid showing points A, B, C. Write down the coordinates of point A along the corridor up the stairs. So along 3, up 5, 3, 5. On the grid, mark it across the point 1, 2 along the corridor up the stairs. There. Okay, label this D. Make sure you do label it D. On the grid, mark across a point E. So the quadrilateral ABC is a kite. So we've got loads of options really. We've got a few options. So A, B, C, E is a kite. I can put it there, I can put it there. They're both acceptable. So this is a kite. That is a kite. Okay. The bar chart gives information about the number of students in Year 11 classes at Tronton School. Okay. First of all, what fraction of the students in the Year 11A class are girls? So Year 11 is here. A. So I've got 14 are boys, and I've got 15 are girls. So the fraction will be 15. Now I might be tempted to put 14 here, but it's not out of 14. You've got to add them together to give what it's out of, which is 29. We could cancel, well, we'll see if it can be cancelled down. It can't be, so that's fine. Shola says that there are more boys than girls in Year 10 Tronton School. Is she correct? Right, so we've got to add all of these up. So I'm going to do boys first, which is 14. This one here is 12. That one there is 8. That one there is 4. So I need to put 14 plus 12 plus 8 plus 4 equals boys. So what's that? That was 14 plus 12 plus 8 plus 4 plus 38. Boys. Right, for girls, black one, got 15 already. This one here is 11. That one there is 7. That one there is 5. I'm putting rings around these just so I know that these are girls. Okay, so I have to put 15 plus 11 plus 7 plus 5. 15 plus 11 plus 7 plus 5 equals 38. So you have to say no. Shola is wrong. There are the same boys as girls. Part of the same question. The pie chart gives information about the 76 students in the same 4 Year 11 classes at Tronton School. it says it's more difficult to find out the number of students in a pie chart than from a bar chart. Is totally correct. Give you reasons for the answer. Well, it definitely is more difficult to find out. Now, on this pie chart here, we actually haven't got any numbers. All the pie chart says in this state is just proportion. So I could say that there's more 11A girls than 11C boys, but I can't tell you how much more. But I could tell you proportional wise how much it is by measuring the degrees. So I'm actually going to say it is impossible to find out numbers from the above pie chart as pie chart only show proportion. Now, I've got to say, assuming that we don't know that there's 76 students who are in the class, because second we know that, we can work it out. So I have to put assuming we don't know the total amount. An easy way is actually really just to say that a bar chart, you can read straight off the numbers, which is probably a lot easier than what I've actually said. So the easiest way to say a bar chart, you can read straight off the numbers. With a pie chart, you have to do some working out. Work out the output when the input is 4. So it's either just 4 times 3, which equals 12, and then we're subtracting 4, which equals 8. So my answer is 8. Change pen colours for this. Work out the output, work out the input, I should say, when the output is 11. So essentially we're doing the opposite. So here when you say minus 4, we're adding 4. And here where it says times by 3, we're dividing by 3. So it's going to be 11 plus 4, which equals 15. And we're dividing by 3, which equals 5. Okay. Now don't type this one into your calculator as a sentence. Don't do 11 plus 4 divided by 3, because that's a different answer. It has to be 11 plus 4 equals, and then divided by 3 equals, because calculating naturally does BIDMAS, and function machines don't do BIDMAS. What is the value when the input and the output are the same? So we need to think about what values can we put in where we add 4, so we times by 3, and then we subtract 4, it's going to be the same. Now the easiest way is just to guess. So let me try again, times 3 minus 4. So we already know that if we input 4, we get 8. So I'm just going to input 5 to see what we get. So 5 times 3, okay, which is 11. I'm sorry, getting further away now. So I'm actually going to do 3. So 3 times 3 minus 4, which is 5. I'm sort of bridging this gap a little bit, so I'm now going to try 2. 2 times 3 minus 4, which is 2. So my answer is 2. Now if I actually want to do it a smart way, I can make an equation, which is x times 3 minus 4, which is exactly what we're doing. And I want it to equal x. 3x minus 4 equals x, because I've just tidied this up. I want to get all my x's on one side. Minus x makes it 2x minus 4 equals 1 yard is 36 inches. 10 centimetres is an approximation for 4 inches. Work out an approximation for number of centimetres in 2 yards. Okay, don't get confused when it says 10 centimetres is an approximation for 4 inches. That's not the same as estimating. We still got to use this as the... Okay, so 10 centimetres equals 4 inches. Okay, 1 yard equals 36 inches, so I need to times this by 36. 360 centimetres equals 1 yard. And I've done that because it says 1 yard is 36 inches. Okay, now what 1 yard? You have to do 2 yards. 36 can be a tricky number, so I'm actually going to use my calculator. To get from 1 yard to... Sorry, to get to 1 yard to 2 yards, I have to times 36 by 2. Which is 72. So my answer is going to be 72 centimetres. 4% of 150. Now, some people might freak out because that's 234%. Now, I want to do the easiest way. I'm going to do 234. I'm going to use my percent button. And my percent button is there, above my brackets. Of means times. And I'm going to put 150, and I'm just going to put equals. And that's my answer, 345. 10, I need to put these on order of size from the smallest to the largest. Now we can either change them all to decimals, we can change them all into the fractions with the same denominator, or into percentages. I'm just going to go with decimals. To change 3 into 7 to decimals, it's just 3 divided by 7, S to D, which is 0.428571. Okay. If you don't know how to do this, 3 to 7, press your S to D button, so it equals then S to D button, and it tells you anyway. 0.438 is just 0.438, and 7 over 16, 7 divided by 16, 0.4375, and this is obviously 0.43. Now it's easier to do them if they've got the same decimal places. Okay, so 1, 2, 3. If you make yourself full, just agree with this one here. 1, 2, 3, 4. And I'm actually going to ignore the last bit of this just because I don't need these really to work it out. So my lowest one is 0.4238. So 0.85. Sorry, which is 3/7. Okay, then it's going to be 0.300, 0.4300, which is 0.43. And then out of these two is this one here, which is 0.4375, which is 7 over 16. Okay, and my last one is 0.438, which is your 43.8. Remember, the ones in your brackets are the answers. These ones here you're working out, because I sort of like ignored a few things here to make it easier for me to work out, and I've added some numbers. These don't really matter, but that one there does. So it's your answers in your brackets you want. The 5 numbers: 14, 15, 16, 17, 18. From the list, write down a prime number. So a prime number's only got 2 factors. This has got 1, 7, 14. This has got 5 as an extra prime number, so it's talking about that's got 2 because it's even. This one here, it's only got 1 and 17, so that's my prime. That one there has got, it's even, so it's 2, so it's got to be 17. Write down a square number. A square number is a number that you times by itself. I'm just going to write down my square numbers. 1 times 1 is 2. 2 times 2 is 4. 3 times 3 is 9. 4 times 4 is 16. Oh wait, I've got 16 here, so this has got to be 16. Star shape. The star shape is made from a regular hexagon, 6 congruent equilateral triangles. The area of the star shape is 96 centimeters squared. Work out the area of a regular hexagon. Now, congruent means the same, so all of these triangles are exactly the same. Okay, now it's on isometric paper. So what I'm actually going to do is I'm actually going to split this hexagon up into more triangles. Now, I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So I've got 12 triangles. Okay, but I know 12 triangles is going to equal 96. So to get one triangle, I'm actually going to divide it by 12. Divided by 12. I'm going to use my calculator to do 96 divided by 12, which is 8. So I know one triangle equals 8. Now it's only asking for the regular hexagon, which is this bit in the middle. Okay, and this is all made up of 1, 2, 3, 4, 5, 6. So I know 6 times 8, because 6 triangles is hexagon. It's going to be Mexican. 6 times 8 equals 48. So my answer is 48, and the unit's going to be centimeters squared. WXYZ is a quadrilateral. XYV is a straight line. Find my angle marked A. Right. Essentially, every answer I've seen of these, it's always going to involve angles on a straight line, and it is an angles on a straight line. So here I'm going to give my reason first. Angles on a line equals 180 degrees. So I know it's going to have to be 147 minus 180 equals 33. No, I've done it the wrong way around, that's why it's giving me a negative answer. But do 180, take away 147. Here, and ZWX, which is ZWX, okay, equals WXY, which means this one and those two are equal. So those two equal. Okay, work out the angle of ZWX. Okay, so I'm just going to put 33 degrees onto my drawing. Now I know is this angle plus that one plus these two must equal 360 because it's a quadrilateral. And the easiest way to remember this is we normally know that triangles equal 180. So quadrilaterals are going to equal 360 because I made them 180 each time. If we need to go to pentagon, we just add 180 each time. Equals 540 and so on, but we only really care about 360. So 145 plus 33. Okay, 145 plus 33 equals 178. So 178 plus 2, and I'm just going to call the angles x because I know they're the same, because these two are the same. 360. Now to solve this, I need to minus 178 from both sides. Okay, these cancel out, which gives me 2x equals 360 minus 178 equals 182. To get 1x, we divide this by 2. 182 divided by 2 equals 91. So my answer is 91 degrees. 8 tins of beans in 4 jars of jam is 2,080 grams. Total weight of 5 tins of beans is 2,000 grams. Work out the weight of 1 tin of bean and 1 jar of jam. Right. So this is actually a simultaneous equation if you wanted to get technical, but it's a little bit easier than what we think. So our second one is just 5 tins equal 2,000 grams. So to work out 1 tin, we just divide both sides by 5. So tin equals, what is my calculator? 2, 3, divided by 5 equals 400. So, sorry, I should have put B for beans, so both tins. So beans is 400. Okay, now 3 tins of beans and 4 jars of Hamston is 2,800. So I'll put 3 beans and 4 jars equal 2080. Now we actually know what the beans are. Beans are 400. So it's 3 times 400 plus 4 jars equal 2080. 3 times 400, 1,200 plus 4 jars equals 2080. I'm going over the line, but obviously don't do that in the vector exam. Minus 1,200 from both sides. These cancel out to leave me with 4 jars equal 2080, 880. Now we want to get one of them, so we've got to divide both sides by 4. These cancel out, just give me J. 220. So minus 220 grams. There's a couple of ways we can do this question here. We can do it as a two-way table, we can do it as a frequency tree, or we can just work it out. I'm actually going to do it as a two-way table, and I want to do it as a frequency tree for you. So think of a two-way table. We've got boys, and we've got girls. Going down, going across. The other thing we're talking about is whether they walk or don't walk. The thing that we always forget is to put is a total. And we fill in what we can fill. 25 boys and 32 girls. So it's going to be total girls. 2/5 of the boys walk. So I can put 2/5 of the boys, and the boys is 25. That is 10. Okay. Half of the girls walk as well. So I can put half 32, 16. I can work everything else out from here. This must be 15 because 10 plus 15 is 25. This has got to be 16 because 16 plus 16 is 32. Let's go across. It's 26. This one here, I'm just going to add anyway because I've got my calculator, which is 31. 31 plus 26 equals 57. And hopefully if I add these two together, I should get 57. 25 plus 32 is 57, good. Let's read the question. Work out the probability. So a club leader picks a child from the children who walk, and it's important, to the club. Work out the probability the child is a boy. So the people who walk is 26. So it's going to be out of 26. There's 10 of them. So it's 10 out of 26. That's your answer. You can cancel this down by dividing by 2, which is 5 out of 13. I can just do 10 out of 26 into my calculator, and when my calculator focuses again, it tells me exactly it's 5 out of 13. Now, if you want to do this as a frequency tree, as this also comes up, there are 25 boys and 32 girls in the club. 2/5 of the boys and half the girls walk to the club. The club leader picks a child from random for people who walk to the club, work out the probability the child is a boy. I have already done this to, for two-way tables, but I'm going to do it if you want to do it as a frequency diagram, if you can. Okay, so I'm going to go up and down, boys, girls, 25 boys, 32 girls in the club. Okay, so I'm going to put walk, walk, I'm going to put don't, I'm going to put walk, I'm going to put don't. So the out of the boys, 2/5 walk. So 2/5 of 25. I'm going to get my calculator. 2/5 of 25 equals 10. So 10 boys walk. Half of the girls, I'll do 16. 16 girls walk. I know 16 girls don't walk. Same with 10 boys walk. I know 15 boys don't walk. So out of people who walk, which is my 10 and my 16, which actually makes it 26. What's the probability that the child is a boy? So a boy who walks is 10, so my answer is 10 over 26. Change 72 kilometres per hour into metres per second. We know this is metres per second, because if it was miles per second, that's quite a fast unit, that's what rocket ships do. So I'm actually going to start with 72 kilometres per hour. Now, I'm going to actually change this from kilometres per hour to metres per hour. And we do this by timesing this by 1,000. So 7, 2, 1, 2, 3. Then I'm actually going to make this metres per minute. And you know that there's 60 minutes in an hour. So what I have to do is I have to change my 72,000 divided by 60, which then gives me 1,200 metres per minute. But I don't want metres per minute, the question's asking me metres per second. So again, I'm just 60 seconds in a minute, so I'm going to have to divide the answer by 60 again, which is 20. So my answer is 20 metres per second. Here's a rectangle made of card. The measurements in this diagram are in centimetres. It leaves fits 4 of these rectangles to make a frame. The perimeter of the inside frame, which is this bit here, is p centimetres. Show that p is ax plus 4y. Now let's think about this. I know this measurement here is the whole length, which is 2x's. So I've got 2x here, and at the bottom I've got the same. So I've got 2x plus 2x. Now my length from there to there, all of this would be 2x, but then I have to subtract this length, and I have to subtract that length. So really, going up would be my 2x's minus 2y's, because 2x is my whole length, and that's a y, and that's a y. So I've got 2x minus 2y, and I've got the same on this side. I've got the whole of 2x minus 2y again. Now if we put all our x's together, I've got 1, 2, 3, 4, 5, 6, 7, 8. So I've got 8 x's, and I put my y's together, I've got negative 4y, which is what it's saying there, 8x minus 4y. Right. Magda says, when x and y are whole numbers, p is always a multiple of 4. Okay. So I'm just going to write this down again. P equals 8x minus 4y. Okay, so for x and y are always whole numbers, this is going to be a multiple of 4. Now, the best way to do this is really factorise. And I can factorise 4 out of both to give me 2x minus y. So I can say the brackets number in the brackets must be whole. Then multiplying it by 4 will make it a multiple of 4. The other way you can think about it, and I'm going to write this down, this number here must always be a multiple. It's a multiple of 8, and all multiples of 8 are multiples of 4. And this one here, you're timesing it by 4, so that's a multiple of 4. So I've got a multiple of 4, take away a multiple of 4, would actually always leave me with a multiple of 4. For example, 40 take away 12 gives me sorry, 28, and 28 is a multiple of 4. Right, question 18. That's centre of a semicircle is on DC, which is actually this line here. Essentially, just find out the shaded region. Right, we need two formulas for this. We need formula trapezium, which you'll normally see is half A plus BH. And essentially, this means top plus your bottom times your height divided by 2. Okay, and then formula of two semicircles, which is actually a circle, which we're going to take away. So for this one here, I'm going to do half. A is 12, B is 28, and I'm going to times it by my height, which is 14. Okay, I'm just going to put that straight into a calculator. I'll do 12 plus 28, which is my 40, so there's 14 in the brackets, times 14 divided by 2. So my whole trapezium is 280 centimetres squared. Now I've got my circle here and here. So two semicircles make a circle, so I'm not going to bother working out an area of a circle then halving it just to double it up. I'm just going to work out one area of a circle. Pi r squared is area. Pi r squared sounds like area to me. So r is my radius, which is my middle point out. Now if I halve this, I get 6, which means from there to there is 6. So from here to here is 6, which means 6 is my diameter. So my radius is actually going to be 3. So it's going to be pi 3 squared. Okay, I'll do my calculator. My pi button's down there. It might be different than yours. Pi times 3 squared. Okay, which is 9 pi. And then we have to take it away. I'm leaving this as 9 pi just to keep it as correct digits. So 280 take away 9 pi. Okay, so it's 280 take away 9 pi, which equals 251.72566. Now the question actually says to 3 significant figures. First significant figure, second significant figure, third one. So I'm looking at that one there. My 7 will actually push this up to make my answer 252 centimetres squared. As if he's going on holiday to Turkey. The exchange rate is €1 equals 3.5601 lira. Average change is £550 to lira. Work out how many lira he should get, give your answer to the nearest lira. Right, so if I know the exchange rate is 1 to 3.5601, if I want 550, I'm treating it as a ratio. I'm going to have to times this by 550 to get the equivalent ratio. So I'm going to have to times that by 550. So times by 550, 3.560601 times 550 equals 1958.055. Okay, for the nearest lira, that's 1958 liras. Okay, as if he's a pair of shoes in Turkey. The shoes cost 210 lira. Aris does not have a calculator. He uses £2 equals 7 lira to work out the approximate value of shoes in pounds. Use 2 equals 7 lira to show the approximate cost of the shoe is £60. Right, as if does not have a calculator, you do. You can still use a calculator to do this. Right, so what I'm going to do is I know that £2 equals 7 lira. So what I'm actually going to do is I'm actually going to change it to £1 equals 3.5 lira. Okay, because I've got a calculator. Okay, I'm just going to times sorry, because it's 210 lira, I'm actually going to do 210 divided by 3.5. So 210 divided by 3.5, which equals 60. So that equals 60. Okay, that's why I can do it. Okay, because obviously I've got a calculator. Now what I assume what they want, because you could do it a different way. Let's say £2 equals 7 lira. Okay. By that logic, I also know that £20 equals 70 lira. So I can double this to make £40 equal 140 lira. And if I add these up, I'll get £60 equals 210 lira. Okay, that's why you got £60. Okay, right. Is £2 equals 7 lira a suitable estimate? Right, now, so we know £2 equals 7 lira is £1 equals 3.5 lira. The actual question is telling us that 1 lira equals 3.5601. Now, if you look at this, 3.5, that's fine. It's 601. So this is really like 1/100th of a lira. So that'll only come to an issue if we're multiplying by 100. So I'm going to say that 3.5 is a good estimate with a 1/100th of a zero, I'm going to say error interval, which is a nice maths word to use. 6 terms of Fibonacci sequence 1, 1, 2, 3, 5, 8. Find a 9th term. Right, the Fibonacci sequence is the first two terms equals the second term. So 1 plus 2 equals 3, 2 plus 3 equals 5, 3 plus 5 equals 8. So we need the 9th term. 5 plus 8 equals 13. Okay, 13 plus 8 equals 21. 21 plus 13 equals 34. Let's see, that's my first term, that's my second term, that's my third, fourth, fifth, sixth, seventh, eighth, ninth. So my 9th term is 34. Okay, right. First three terms of a different sequence is A, AB, A plus B. So that the 6th term is 3A plus 5B. Right. First term, second term, third term, 4th term. So my 4th term is these two added together, which would be 1A and I've got 2 B's. My 5th term would be these two added together, which would be 2 A's plus 3 B. And my 6th term, which is the one that we want, is these two added together, which is 3A and 5 B's, which is what it's asking us to show. Right. The 3rd term of the sequence is 7, 6th term is 29, find A and B. Right, we know that the 3rd term, if we look at this, is A plus B. So I know that A plus B equals 7. And I also know that my 6th term is 3A plus 5B. So I know that 3A plus 5B equals 29. Okay, this is a simultaneous equation we just have to solve. Okay, now I always go down the elimination route for these. So what I'm actually going to do is I'm going to times this one by 3 to actually make this 3A plus 3B equals 21. Okay, now my A is equal, so I'm going to subtract this one from that one. 30 minus 3 is nothing. 5 minus 3 is 2B. 29 minus 21 is 8. So to make 1B, I divide them both by 2. So B must be 4. So if B is 4, now I need to make A. I'm going to use this one to substitute it in. So I've got A plus 4 equals 7. Minus 4 minus 4. A must equal 4, 5, 6, 7. A must equal 3. There's your answer. In a survey, the outside temperature and the number of units of electricity used for heating were recorded for 10 homes. The scatter diagram shows this information. Okay, my outside temperature is on the bottom, my number of units are on the side. Okay, first question is, Molly says, on average, the number of units of electricity used for heating decreases by 4 units for each centigrade increase in outside temperature. Is Molly right? So what is she saying? She's saying if 10 you read up, and that's 63, okay? If we go 1 degree over, it should go down to 4 less. Now, because of the scales, well, first one, we'll draw a line best fit. Okay, right now, because of the scales, I'm going to find it quite hard to read 1 degree over. So what I'm actually going to do is I know 10 degrees centigrade, sorry. If I go up, I go around, is about 62. I'm going to read 20, okay? So I know that 20 degrees equal, I'm saying that's 33. Now I chose 10 and 20 just randomly. I could have chose 0 and 10, or I could have chose 20 and 30. But what this can tell me is I know that 10 degrees is actually going to be 29 units, because all I've done is subtract it. Okay, so I know that 1 degree is actually going to be 2.9 units. Now from this, 2.9 is nowhere near 4. So I'm going to have to put no, Molly is wrong. A change of 1 degree is 2.9 units. Decrease. Right, here's the second part to this question. Why should you not use the line of best fit to predict values under 30? Now this is my line of best fit. Now values under 30 is here. But what you really have to think about is that my low score is 20. So all of this value here in my graph, I can't really make predictions for. Okay, and the reason is Now something weird might happen below 20 degrees. So for example, if temperature goes above 20 degrees, something weird might happen. So let's say that at 20 degrees heating shuts off and this goes straight down to 0, or if at 20 degrees people think it's hot enough to go on holiday so they turn the heating off. It's actually called extrapolation. So you'd have to say 20 degrees, anything above 20 degrees, we cannot use a scatter graph to use because we're extrapolating the data. Then we need to think about having a water meter. There are two possible ways you can pay for it. You can have no water meter, which is a charge of £107 per year, or you can have a water meter, which is £28.20 per year, plus 91.22 pence for every cubic metre used. 1 cubic metre is 1,000 litres. Now the main issue I have with these questions is that as a child doing a Gcse, you couldn't really care less about your water meters. But most houses, a water meter, what it does is it charges you. Now if you walk down the street, sometimes you see little grates outside your house. Okay, you'll either have a main or a meter. A main, they can't measure how much you use, so they charge you per month. A meter, they can measure it, so they charge you per usage. But anyway, our water meter. So he uses on average 180 litres a day. So if he does 180 litres per day, we want to work out how much he does per year. There's 365 days in a year, so we need to multiply these together. 180 times 365, which is 65700. Okay. That's how much he uses per year. So now we have to work out how much it costs him. Okay, so this is actually in litres. So we need to change litres into cubic metres. If it's 1,000 litres is 1 cubic metres, we need to divide this number by 1,000. I'm just going to use my calculator for every single bit here, because I can. 65.7. So this is our cubic metre. Okay. 91.22 pence for every cubic metre, so I need to put 65.7 times 91.22p. Please remember this is in pence and not in pounds. It's quite a common mistake people make. Times 91.22, which equals a big number, 5993.154. Okay, this is in pence, so I'm actually going to change it into pounds, making it £59.3154. This level of accuracy is too much, but I'm doing it anyway. Remember, you've also got the charge of £28.20. So £28.20 I need to add on. So 59.3154 plus 28.2. Okay, which is 87.5154. Okay, in real money that's 87.52 because we can't get less than a pence. £107 charge of a water meter, so he should go on the main. Can write it down. He should go on water main. It will be, and you don't have to put the numbers in, but let's just do it anyway. Minus 107. I've done it the wrong way around, so give me a negative answer. So it will be £19.48p cheaper. Two companies. Table shows information about the sales of a company and the number of workers for each company in 2002 and 2014. Work out the percentage increase in sales from 2004 to 2014 for company A. So we've got 320, and we need to make that to 388. We need to work out the percentage change. Now, I'm a big fan of ratio bars, percent bars I mean, so I actually know that 320 is actually equal to my 100%, and 388, oh it's actually higher, 388 actually goes on the top there. So we need to work out how to get from 320 to 388. Right, so what I'm actually going to do is I'm actually going to work out what £1 is, and we'll do that by dividing 320. So this side I've got to do the same, divided by 320. So I'll do 100 divided by 320, which is 0.3125%. So £1 is 0.3125%. We don't want £1, we want 388. So I need to times it by 388. So this side I've got to times by 388. And so times 388. Okay, so that's 121.25. Okay. But my answer isn't 121.25 because my change is actually 21.25%. So that's my change, 21.25% increase. Second part of the question. Which country had the most sales per worker in 2014? Company A or Company B? Now, I'll be honest, I've never heard of the unit sales per worker, but essentially I know that per means divide, as in percent, you divide by 100, or miles per hour, you do distance divided by time. So we're doing sales per worker, Company A or Company B in 2014. So I've got 388, which is my sales for Company A. My worker is 3200, so I've got 388 divided by 3,200. For Company B, 57 divided by 640. 57 divided by 640. So I'm right down there. So I'm just going to put them into my calculator. 388 divided by 3200, which is 0.12125. And 57 divided by 640, which is 0.089. So let's think. This means that essentially 1 in every 100 workers make a sale, and this means 1 in 10 workers make a sale. So I'm going to have to say Company A has higher sales per worker.